Nice. So section 2.2 is going to continue work with kind of descriptive statistics and summarizing things. We're going to work with histograms. So a histogram is basically taking our frequency distribution and plotting it using these types of bars. So to get started though, let's look at problem number 6 and the histogram that we have there. And let me ask you a couple of review type questions just to try and reinforce a couple things we learned in the previous section. And that is, for this frequency histogram, we can look at the different classes of weights of quarters. And in this particular case, let's look at this first class. It says we ask for the class width and the class limits of that first class. Let's start with the class width. What's the class width of this first class? Yeah, 0.1. So that's how wide it is. So it's the distance between these two, upper and lower class limits. So the class width, ideally you'd be subtracting adjacent class limits, like adjacent class lower class limits or adjacent upper class limits, but in this case the class width is 0.1. Let's look back at this. Can you tell me what the lower class limit and the upper class limit is for that class? Remember, we're recording this, so make me look good. What's the lower class limit? 5.5. Thank you. 5.5. And the upper class limit? 5.6. So anything between 5.5 and 5.6 is going to be in that class. Oops, wrong way. Let's zoom out a little bit. So just kind of a quick review problem, highlighting some of the stuff we did in section 2.1. But in this section, like I said, we're going to go on and learn a little bit more about displaying these things. And when you display these, you can see different types of shapes. So let's look at a few common distributions, a few common shapes that you'll see. Now, of course, there's no limit to the different shapes you can see, but these are some typical ones that I want to highlight. A lot of you have heard of the bell distribution, a bell-shaped curve. So a bell-shaped curve is something like this. Typically you get it when you're talking about heights of individuals. You have a bell-shaped curve. A lot of heights are, around this middle point, this midpoint, median, mode, whatever you want to call it. And then you get people trailing off to either side, some people who are altitudinally challenged, and some people who are playing professional basketball. So one side of the coin or the other. Another possibility is you can get evenly distributed data. So data that is so-called uniform. Now, one of the problems in at least the last edition talked about the frequency with which people are born on a given day. Now, I would naively expect that you would get more or less a uniform distribution. I mean, babies don't know the calendar. They don't know what day they're coming. But when you actually look at the data, that's not true. You'll see that on Saturday and Sunday, there's a huge drop-off. Why? Well, some people need cesarean sections, C-sections, and those aren't scheduled on the weekends typically. So they're going to be scheduled during the week. You're going to have higher frequencies during the week. Okay. You can have data that's skewed to the right or skewed to the left. Now, if this is skewed to the right, this is skewed to the left, what do you think the skew means? I mean, these kind of look like a bell shape, but what do you think the skew means? When I say it's skewed right, how come this is skewed right? Yeah. Like outliers? Yeah, it's the outliers. It's where the tail is. So you got a tail that trails off here more to the right, and this one is where it tails off to the left. So skewed right and skewed left. So different types of distributions depending on your particular data. Now, there's really no limit, but those are just a few common ones. Okay, Let's take a look at problem number nine. From section, problem number 18 from section 2.1. This is some nice data there. And actually, you know what? I think it's going to be problem number 17. Let's take a look at our Google spreadsheet. Let me remind myself as to which data we have here. I think it's, well, let me not guess. Let's just take a look here. All right. So it's problem number 18. If you scroll down in your data set, you should be able to see the data from problem number 18. So this was respondents to that California Health Survey. You know what? No, I think, no, that's wrong. This is problem number 17. So yeah, I was right. My institution said that didn't look like data set from number 18. So this is data set from problem number 17, and it's the height of statistics students were obtained from the author as part of an experiment conducted for class. So here we go for problem 17. And what we're going to do is we're going to construct a frequency histogram. We're going to tally these things up and display their heights depending on how many zeros, how many ones, twos, etc. that you ended up with in class. So let's do that. Now essentially what we need to do is we need to input a chart. And from Google, to input a chart, go to the Insert button and go down to Chart. Now depending on how wide your screen is or how you have your display set up, sometimes you can see the chart icon across the top bar. Not in my particular case, my screen isn't wide enough. At home it is. So let's go down and select Chart. And first tell it, well, what are we going to chart? What kind of chart do we want? So you should see something like this, a chart editor. Let's click that little drop-down triangle. And you have to scroll all the way down to the bottom. And underneath Other, you'll find the chart that we want. So first row, middle column is a histogram. Yay! We next need to tell Excel or Google where you're going to have the data. So you can do that by clicking here and just inputting the range, or you should also be able to click and drag. Now, I can't see my data very easily here, so I'm trying to remember where the data is. I think it's A55, 55, let's just go over here. A55 to, is it A90? Or how far down does that go? A90? Alright, so let's just close that and move this out for just a second. How come it's not letting me move that? Move. Okay. There we go. Alright, so I was right. A55 down to A90. Good. So you should get a chart that looks something like this. But it'd be nice if these cells here, these classes, were a little bit more evenly divided. In fact, it'd be nice if I had the zeros, the ones, the twos, etc. David, still running into some problems? It's time for a new computer. All right, okay. If it started out with data in it, just type over the data that you have and select the range. Well, let's see if we can make it look the same this way. So let's go up and edit it. So if you click these little buttons, one of the options is to edit the chart. Make sure that your data range matches mine. And then let's go to customize. The second one down is for histograms. And one of the things I don't like, maybe this is what's causing our disparity here, is the width of our classes. It's kind of arbitrary. So I want the width of my classes to be 1, and that's the bucket size. So select bucket size and then select 1, and let's take a look back at our chart. So how are we looking at it? Now it's the same? Good deal. All right. There's other things you can do here. I'm not trying to make you an Excel or Google wizard here. This is statistics. The nice thing about this is you can see the frequencies, and if you trace over things with your mouse, you can see even a little bit more. When you put your cursor on column 1 here, it shows you the class that you're dealing with. It's 0 to 1, and the count, the frequency count in that class, and so on. And that's true for all your classes. There are some things you can change. You can change a lot of things. As far as what I want you to know, one thing that I do want you to be able to do is title these things. So the third option down in terms of customize is type in a new title. So let's do that here. Let's call this problem 17, section 2.1, and then you can put in your name. 2.1. There you go. So it's nice when you save your work in Excel or Google and send it to me. I'd like these things titled from you. One last little thing that I find handy is if you go down to horizontal axis, notice how these numbers here are listed horizontally. Sometimes that makes your chart a little bit crowded. You could uncrowd things if you enable the slant labels. So let's go down to slant labels, and then I can put these on an angle. You can do 60 degrees, 90, 30, or anything in between. Here's 90. But it just gives you a little bit more breathing space on the x-axis. So maybe that's helpful, maybe it's handy, maybe it's not. It's up to you what you find convenient. The bottom line for you is that I'd like you to be able to come up with a frequency histogram and then interpret it, be able to look at it and make some conclusions. So in this particular case, these represent the height of students. Do you think we're running into the same problem that we ran into when we were talking about people's weights? Do you think people actually know exactly how tall they are in inches? More or less, but did they know exactly? It seems like there's a lot of people that fell right here. So one of two things is possible. Either you had a lot of people who were, right in the some range that ended up in a digit of 5 or a 0, or people were kind of rounding, estimating. One of those two possible conclusions. So the goal is to be able to get the data displayed in a nice way and then draw some conclusions from that. Now, once you've created your histogram, you can look and decide, gee, is this normal? So what do you think? Is this a normal or bell-shaped distribution? Yeah, I might say left, but it's certainly not normal. All right, it doesn't have anything close to a bell shape. Now, there are ways to decide if things have a bell shape, and your author does something in the 13th edition that I don't really remember him doing much in the 12th edition. That is, he introduces a normal quantile plot really early. So let's take a quick look at that. It's beyond us right now to understand what the normal quantile plot means, but what you're looking for is plots that look like they fall, kind of randomly along a straight line in this normal quantile plot. If that's the case, then you've got something that's just a normal distribution. If there are patterns in it, like this one, these are all straight up and down and then trail off, or if it kind of has this nice curvy shape, above, then below, then back above, again, it's not a normal distribution. You're looking for something that's nice and evenly spaced around these normal quantile lines. Let's take a look at these four problems, A through B and number 18. Let's start out with the easy ones. Does this look like it represents normal data based on the normal quantile plot? No. How about D? All together. Come on, yes or no? No. All right, thank you. How about C? Is that normal data? Yeah, that one looks pretty normal. And A is a little bit tricky, but what do you think about A? No. And it's tough. Later on in the course, we'll learn some objective ways to decide this, but because there's a little bit of a pattern here in terms of its curve, it's not normal. It's not coming from a normal distribution. So I'm not going to give you anything that's tough. I would make it really, really obvious. Something like this or something like this is the kind of thing that I would put on a test. Until we have something more objective, I'm not going to ask you to get really subjective with these things. Okay, so for homework, so section 2.2 homework. Try 1 through 9. Those are just the odds. If you're working with the 12th edition, it'd be 12th edition. That'd be section 2.3 from the 12th edition. Try 1 through 15. Now for problem 15, you're going to need to access some of the data that the book has. You'll find that on the course website, D2L. I've got all the data sets downloaded, I think into Excel spreadsheets. You can open them from there. Good luck with that.